Hello student. In the last class, we come to know what a equivalent relation is. We define reflexive, symmetric as well as transitive relation. In this lecture, mainly we are going to discuss question based on all of this three relation. So without any further ado, let's get started. The first one, we need to tell me whether relation R1 is equivalence or not. So let's start with whether that particular relation is reflexive or not. For a reflexive relation, a particular element X must associate with itself. Right here, both the elements of the line, both the elements are line actually. So we need to show whether L1 and L1 are related with relation R1 or not. It implies that we need to prove that whether line L1 is parallel to line L1 or not. Since both the lines are identical, that means are coincident. Coincident line are actually parallel, so that will make your relation is reflexive one. Second one, we need to check whether relation is symmetric or not. For symmetric relation, the way element L1, L2 belongs to relation R1, we need to prove with the same relation L with the same relation L2 comma L1 must belongs to relation number R1. L1 L2 if it is belongs to R1, that means it is given that line L1 is parallel to line L2. Based on this information, we need to prove that L2 is parallel to L1. Since both the things are identical actually, so there is no difference in L1 parallel to L2 or L2 parallel to L1. So this will make your relation is symmetric. Third and the last one, which is your transitive relation. To prove whether your relation is transitive or not, let us it is given that L1 and L2 is associated with the relation R1. It means it is given that L1 is parallel to line L2. Now let me introduce another line L3 there, and I'm assuming that L2 and L3 are kind of element which belongs to relation R1. It means line L2 is parallel to line L3. Based on this information, if we successfully prove that line L1 and L3 are parallel, that means your relation will be equivalent or transitive, otherwise not. So it is given that these two line L1 is parallel to line L2, and we later on we designed a line L3 such that it is parallel to line L2. So can't we say, or isn't it obvious that line L1 and L3 are parallel to each other? So this will make your relation transitive. So R1 is an equivalent relation. Now let me move to the quickly move to the next one, where x comma y are element associated with the relation R. Relation, it is given that x minus y is divisible by n can be any real number except 0. N can be any real number except 0. So based on this information, let's try to figure it out whether particular function is reflexive or not. So to check whether your function is reflexive or not, elements, let me check whether x comma x is a part of relation R or not. It implies I need to prove that whether x minus x is divisible by n or not. I know x minus x is 0, and hence 0 is divisible by any real number except 0. So any real number except 0. So that will make your relation is reflexive. Now, if I need to check whether your relation is symmetric or not, for symmetricity, it is given that xy belongs to R. We need to prove that y comma x ordered pair by switching the position of x comma y must belongs to R. X comma y belongs to R. It indicate that x minus y, it is given that it is divisible by n. So if it is divisible by n, that means x minus y will be equals to some lambda times n, where lambda being any integral value. Am I right? So based on this information, we need to prove that y minus x is also divisible by n. Sorry, y minus x is also divisible by n. So may I write this y minus x as negative x minus y? Now I already know that this x minus y is actually integral multiple of n. That means it is equals to negative lambda times n, which prove that your y minus x is also a negative or positive integral multiple of n. Hence y minus x is also divisible by n. That will make your relation symmetric one. And the third one, where we need to prove that our relation is transitive. So to prove your relation is transitive, you need to focus upon two ordered pair, one which is given to us xy, it is belongs to R. That means somehow we know that x minus y, whatever value it be, it will be integral multiple of n. You need to assume a ordered pair of format y comma z. It must belongs to R. That means we also know that this y minus z will be equals to some other integral multiple of n. Let me consider the other integral multiple be mu. And I need to prove that this x minus x comma z must belongs to the same relation z. So prove that I need to use these two, one given and one assumed relation. Once I add these two relation, then what will happen? Addition will take away your y. So if y is not there, that means I have x minus z is equals to n times lambda plus mu. Since this lambda and mu both are integral values, so that will make lambda plus mu is again another integer value. Hence, x minus z is just nothing but integral multiple of n. That will make x minus z divisible by n. So hence your relation is also transitive one. In the next one, we need to check whether that particular relation is equivalent or not. Again, let's start checking whether it is a reflexive one or not. So for reflexive one, what you need to do, you need to check whether a comma a is a part of relation p or not. So p comma p, for that one, you need to replace your b with the a or vice versa. So that will be secant square a minus tan square a. You need to prove that this result is equals to 1. Since we know from the trigonometric identity that 1 plus tan square theta is equals to secant square theta, from there I know that the value of secant square minus tan square will be equals to 1. Hence, for any particular value of theta, let it be a, this secant square a minus tan square a will be equals to 1. So hence, it is given that 1 is equals to 1. That will make your relation reflexive. For the next one, it is your symmetric. For the symmetric one, I need to prove that the way a comma b belongs to relation p, the b comma a must belongs to the same relation p. That means from the given relation, I need to prove that secant square b, value of secant square b minus tan square a is equals to 1. It is equals to 1. But what I know is secant square a minus tan square b is equals to 1. So let me use this trigonometric identity again. This secant square b can be written as 1 plus tan square b. Am I right? Similarly, this tan square a thing can be written as secant square a minus 1. Secant square a minus 1. So now this relation is nothing but 2 minus secant square a. Let me take out negative 1 as a common, minus tan square b. And from a given relation, since a comma b is a part of relation p, the value of secant square a minus tan square b is 1. Thereby, the value of this expression is equals to 2 minus 1, which is 1. So that will make your relation a symmetric one. Now the last one which I need to prove that my relation is transitive one. So to prove whether my relation is transitive one or not, it is given that a comma b is a part of relation p. That means I know that value of secant square, a value of secant square e is equals to, let me swap this tan square b on the other side. It is equals to 1 plus tan square b. With the use of trigonometric identity, this 1 plus tan square b, it can be written as secant square b. Am I right? So this is the relation when a comma b ordered pair belongs to p. Now you need to assume that there will be, definitely there will be a c. So b comma c must belongs to relation number p. So from there, I can write that the value of secant square b must be equals to secant square c. So this will be your relation number 2. And from these two relation, you need to prove that with the same logic, a comma c ordered pair should belongs to p. If it does, then this is your transitive one. If it doesn't, then relation will not be transitive one. That means you need to prove secant square a is equals to secant square c. Now from relation number 1 and 2, it is clearly visible that the value of secant square b is equals to secant square a as of secant square c. Hence prove this is the relation which what we are looking for. So your relation is said to be transitive one. Let me take another one quickly. R1 is a relation in R being any real number, such that R1 correlate ordered pair or element x to y. Relation is 1 plus xy is greater than 0. It is given, then R is what? Whether it is the equivalent relation or not. So let's try our luck whether your relation is reflexive or not. So to make your relation reflexive, x comma x, a particular order pair must belongs to relation number R1. That means we need to prove that the value of 1 plus x square is greater than 0. Since 1 plus x square is a quadratic expression, if you are aware, so if it is a quadratic expression whose d discriminant is lesser than 0. So for a quadratic expression whose value of d is less than 0 will give you always positive value. It is always will give you values which is always positive for all x belongs to R. Her real number may it will always be positive. So hence this is what we need to prove. Your relation is greater than 0. That will make your relation reflexive. To check whether your relation is symmetric or not, for symmetricity, the way element x comma y belongs to relation R1, you need to prove that with the same relation y comma x also belongs to relation R1. So for that one, swap the position of x comma y there. Since it is given that 1 plus xy is greater than 0. So from this information, swapping the position of y and x will not change the actual expression. Still, it is 1 plus xy, and from the given relation, the value of this expression is something which is greater than 0. So it is obvious if relation if 1 plus xy is greater than 0, then obviously 1 plus yx will be greater than 0. That will make your relation symmetric one. To check whether your relation is transitive or not, now it's a bit tricky. Since xy is belongs to relation R1, that means we know 1 plus xy is something which is greater than 0. And you need to assume that y comma z also belongs to relation R1. That means 1 plus yz is also greater than 0. Now you need to prove that 1 plus xz is greater than 0 for transitive relation. But in inequality, you can't just swap the position of y or put the value of y from relation 1 to 2. For that one, you have to do your base to prove that relation is not transitive. Even a single element is sufficient to prove whether your relation is not transitive. To make it transitive, single element is not feasible. So do not try to put values of x and y which are positive. Otherwise, it will make the value of 1 plus x z. Obviously, it will be positive. If you are taking intentionally, if you are taking x and z a positive value. So if I had to check my luck, then let the value of x be 1. If x is 1, then I should check or I should put the value of y which is negative. So what should be the negative value in your mind then? Negative value, let me take any rational value, let it be negative 1 by 5. So I know 1 minus 1 times negative 1 by 5, still it is greater than 0 because we are getting positive values for 4 by 5. This is what is given. So do not choose the value of x and y in such a manner that will make your 1 plus xy negative. Now, since we know value of y is negative 1 by 5, choose your value of z wisely so that 1 plus yz will become positive. So if y is negative 1 by 5, y is negative 1 by 5, let the value of z be 3. Let the value of z be minus 3. Or all right. So if I'm taking my value of z is negative 3, so 1 plus negative 3 times negative 5 is still positive. But the moment I put the value of x, which is 1, and z, which is negative 3, this 1 plus xz particular function will give me a negative response. So as I told you, a single a single ordered pair is sufficient to prove your relation is not transitive. Even some finite elements may be not so sufficient to prove whether your relation is transitive or not. So try your best if you got stuck in a inequality to check whether your relation is transitive or not. Anyway, this relation is not transitive, so this relation R1 is not equivalent. I hope you understand this bunch of example. I have just attached a couple of question for your reference. So do try it out if you can, and do let me know if you face any difficulties there. Thank you very much.